Okay, the next step in the process is this. We know now how to build up functions by using the unit step function, but what we need to do then, if we were going to solve a differential equation involving one of these, would be to compute its transform. So here's one that's relatively simple, and let's first of all write down the formula for this function, and then we will figure out what its transform is. Okay, f at t in this case is equal to, well, this is just equal to 0 until you get to 1. So ut minus 1 goes here, and that will jump it up to 1 at t equals 1. And then I'd like this to drop back down to 0 at t equals 2, and we learned how to do that in the last segment. So you subtract off ut minus 2. Now, how would you compute the transform of a function like this? Well, let me show you a couple different things about that. The first one is this: if I simply want to use the formulas, this actually becomes quite easy. ut minus 1 and ut minus 2, those are things we can look up on our list of transforms. We have already learned how to compute a number of transforms, but let me see here. I don't know if we do essentially have it right here, and that is what we're doing is we're transforming ut minus a times f, where f is the function that's just equal to 1. Well, what is the transform of the constant function 1? Well, it's 1 over s. And notice, if you take 1 over s, its graph is a horizontal line at a height of 1. If you were to shift that left or right, it would not make any difference at all, right? So you could think of this as the 1 function that is of the 1 function that's shifted to the right by 1 unit, or just as the 1 function. It doesn't make any difference. So what you'll have is e to the minus as, where a is that point of discontinuity, times the transform that you get just of the original function. Well, the original function is 1, which has transform 1 over s, and we're jumping at 1, so this is e to the minus 1s. Then we subtract off the transform of this function, that's e to the minus 2s, and the 1 over s takes care of the fact that this is being multiplied by the function that's always equal to 1. Well, that's it right there. We have now computed its transform, and I suppose you could write it in various ways. That there's really nothing wrong with this, but you might see it written in this kind of way here: e to the minus s minus e to the minus 2s. And I suppose you could factor an e to the minus s out of here. So there's all sorts of things you could do, but all of those are perfectly good representations of the transform of this function. So that's how you do the translation. Now, one of the things that is left unstated here, though, is why is it that the transform of this product is equal to this right here. So let's see if we could come up with that formula, and we'll do that in the next segment.